Okay, in this video I'm just going to do a really basic universal gravitational calculation. Nothing tricky here. I'm just going to determine the force of gravity between the Earth and the Moon. So because we're not dealing with the force of gravity on the Earth or anything like that, we have to use the big universal gravitational equation. This guy. So if we imagine here's the Earth and here's the Moon, we're really supposed to be going from the center of one object to the center of the other object. But the issue here, for radius, but the issue here is that the distance from the Earth to the Moon is much bigger than the Earth or the Moon, so their actual radiuses don't matter. This is really probably more like this, and we're interested in this R right here. Right, these guys are much smaller than the distance between them. So, all we're really going to do here is plug in the values that we'd look up from a chart. The universal gravitational constant, 6.67 times 10 to the negative 11. Mass of the Earth, 5.98 times 10 to the 24. It doesn't matter which one is M1 or M2, right? Like, these are multiplied with each other, so it doesn't make any difference who's who. Mass of the Moon, 7.36 times 10 to the 22. And the distance between the Earth and the Moon, on average, is 3.84 times 10 to the 8 meters squared, so it's kilograms, and this is in newtons, meters squared per kilogram squared. So the meters squared will cancel it with the meters, and the kilograms will cancel it with the kilogram squared, and we'll be left with just newtons. With a big calculation like this, I will put it into my calculator twice to make sure that I didn't make a mistake as I'm doing it. So I think I got here 1.99 times 10 to the 20 newtons. And I'll just hit that again, make sure I didn't mess it up. I think that's right, but I'll just... Yeah. So there you go. That's a pretty big force of gravity, but you have to remember it's acting on a very big object, so it's actually not going to lead to that much acceleration. Why don't we do that? If we say that that's the net force acting on the Moon, assuming the Sun is far enough away that that force of gravity isn't really that critical on it, 1.99 times 10 to the 20 newtons. The mass of that Moon was 7.36 times 10 to the 22 kilograms, and so what's my acceleration? Zero 0.0027 meters per second squared. So there you go, a relatively small acceleration, big force but even bigger Moon, so we get a pretty small acceleration, and that's what causes the Moon to continue to orbit around the Earth.